Now this is the final video for this chapter. Our heart will beat anywhere from 60 to 80 cardiac cycles in a minute. It's usually, if you're healthy, that's your heart rate, anywhere from 60 to 80. Your heart rate is determined by cardiac output, how much blood you pump out of the pulmonary circuit and the systemic circuit in 1 minute. How much blood's pumped out in 1 minute. And the cardiac output is determined by the amount of blood that's pumped in a heartbeat. So that's called stroke volume. Cardiac output is how much is pumped out of the ventricles in 1 minute. How much is pumped out in one heartbeat is your stroke volume. So your stroke volume times how many cardiac cycles, how many times your heart beats in a minute, that gives you your cardiac output. If we know our stroke volume and we know our heart rate, all we got to do is multiply them. So in an average heart, your resting stroke volume is equal to 70 milliliters because your end diastolic volume is 120 and your end systolic volume is 50. So you're going to pump out 70 milliliters every time your heart beats, and you multiply that by your heart rate. Now, with your stroke volume being around 70 milliliters per beat, there can be a different range, and sometimes it's hard to measure it directly because it can be from anywhere from 50 to 120 milliliters. So they use something called ejection fraction to measure it. That's the percentage of blood that's ejected every time the ventricles contract. Normally it's around 50 to 65%, and this value is supposed to be equal for both ventricles. And there's 3 things that affect your stroke volume: preload, the contractility of your heart, and afterload. Preload is how much and to what degree the sarcomeres in the ventricular cells stretch before they contract. And the degree of preload is determined by your end diastolic volume, how much blood is drained into the ventricle in the filling phase. And 2 factors influence this end diastolic volume: how much time the ventricle spends in diastole and how much blood returns to the right ventricle from the systemic circuit, the venous return. Your end diastolic volume increases if your ventricle spends more time in diastole, because there's more time for the ventricles to fill up with blood. And it will also rise when the left ventricle pumps more forcefully into the systemic circuit. And it'll do that because it returns more blood to the right atrium more rapidly, so it increases venous return. The relationship between preload and stroke volume is explained by the Frank-Starling law. And according to this, it says increased contraction of the ventricular muscle cells stretching will cause more forceful contraction. If they stretch more, they contract more. And so you're going to have a stronger contraction, a higher stroke volume. And that makes sure that the volume of blood that the heart pumps out is equal to the volume that enters it. And this is very important when we're exercising, because our cardiac output has to be adjusted then to meet our body's needs. The contractility of the heart is the ability of the heart to generate tension. and it's hard to measure it directly, so they will look at the velocity of the blood as it's ejected from the ventricles. If you have more contractility, you have more stroke volume, and so you decrease your end systolic volume. If you have decreased contractility, your stroke volume goes down and you increase your end systolic volume. Afterload is the force that the right and left ventricles have to overcome in order to send the blood into their respective arteries. And this is mainly determined by blood pressure in the arteries, in the systemic and the pulmonary circuits. If afterload increases, that means the ventricular pressure had to be greater than what is in the pulmonary trunk and arteries and the aorta and the systemic vessels in order to open those semilunar valves. So if you increase your afterload, it will cause a decrease in stroke volume and a rise in the end systolic volume, where a decrease in afterload causes a higher stroke volume and a lower end systolic volume. So the way, if we look at this, number one, preload of the left heart, that is the volume of blood coming in the pulmonary circuit. We're just talking about the left side now. The contractility is determined by the heart's pumping ability, and the afterload is determined by the pressure in the systemic circuit. So the pressure here, it will open that valve and allow the blood to be ejected. So changes in preload, contractility, and afterload can affect the stroke volume, because higher preload causes higher end diastolic volume. And this stretches your cardiac muscle cells because they've got more volume in them. And when you combine that with more contractility, you get a more forceful contraction. If afterload is low, then that contraction is pumping against a great deal of resistance. And a forceful contraction against low resistance causes higher stroke volume and low end systolic volume. With low preload, that causes low end diastolic volume. So your cardiac muscle cells are not going to be very stretched, and so your heart is going to have less contractility and it will contract weakly, very weakly. But if the afterload is high, that weak contraction is against a lot of resistance, and that will lead to low stroke volume and more blood that's left in the ventricle after the contraction, which is a high end systolic volume.